In this video, I'd like to talk about why counterexamples work to disprove a false statement. All right, so to begin, let's write out a false statement. The sum of two odd integers is an odd integer. Now this statement is false. It's false because if you add two odd integers, you get an even integer. To see that, we could do a little scratch work. Let's say that x is odd, so x is 2k plus 1. Let's say y is odd, y is equal to 2m plus 1. Well, then x plus y is 2k plus 1 plus 2m plus 1, which is 2k plus 2m plus 2, which is 2k plus m plus 1. Now, since if we assume that k and m are integers, then k plus m plus 1 is an integer, so x plus y is even. So it's false because when you add two odd integers, you get an even, not an odd. Okay, so why will a counterexample work to disprove this false statement here? This is because we can rewrite this, right? We can rewrite this as, let me give myself a little room. If x and y are odd integers, then x plus y is an odd integer. All right. Now, rewriting it like this is a way to write it as an if-then statement, but we can go even further. This is actually a for all, right? Because we're saying any, when we say the sum of two odd integers, we're not saying which ones. We're just saying the sum of any two odd integers. This is actually a for all statement. So we can write this as for all x, y, if x and y are odd integers, then x plus y is an odd integer. And it's the for all that is the key piece to help us see why one counterexample is enough, right? Because think about this. I'm saying that no matter which two odd integers you pick, when you add them together, you get an odd. That's what the for all is saying. For all says no matter which two odd integers, x and y, you pick, x plus y is odd. Well, the for all is not true if you find one thing that it's not true for. And so that's why one counterexample will disprove this statement, because I'm saying it works for all of them. Well, if you find one instance where it doesn't work, then it doesn't work for all of them. Right? If I was to say that all people have blonde hair, then what would be a counterexample to that? You just have to find one person with brown hair, or in my case, one person with no hair. And you found someone that doesn't have blonde hair. Then you've disproven the fact that all people, right? Because I'm saying all people have blonde hair. Well, I'm a person that doesn't have blonde hair, so therefore it can't be true for all. In the same way, a counterexample to the statement could be something like x equals 3, y equals 5. which is even. So when you're trying to prove a for all, right, if you're trying to prove a for all, you have to show that it's true for all. That's why we have to be completely general. But when you're trying to disprove a for all, as we are in this case, when you're trying to disprove a for all you have to show is that it doesn't work for one of them. Because if it doesn't work for one of them, then it doesn't work for all of them.